welcome. This is 9.1 for Modern Math, factor by grouping. So our last unit was all about distributing and then also factoring out the greatest common factor. There's other ways to factor, and this is probably going to be one of the most important units that we'll be covering. So please make sure if you have any questions after you watch this video, please come and talk to me or talk to a neighbor. Make sure you feel like you're good with this. Okay, so we'll do a quick review first off. That's just to simplify. So this is just distributing using the distributive property. So 2 times 5 is 10 x squared. Here we've got negative 6x, and here we've got 2 times 7 is 14. All right. Here we've got x times x, that gives us x squared, and x times negative 4 gives you negative 4x. Okay, and then here, let's make sure we understand this. Is when we distribute that, we'd end up getting 3x to the, and remember, when we're multiplying like bases, we'll add their exponents, and this would be like a x to the 1, so we'd end up getting x to the 3. All right, and then we'll distribute to the next, so we have 3 times a negative 2 gives us a negative 6. Oh, sorry, I messed this up. I forgot to write this. Okay, so this should be a 2. This one would be like a 1 if you wanted to write it there. Okay, so that gives us x squared times x squared gives you x to the 4th. And then we'll distribute to the next. That would give us negative 6x to the 3rd. And then we'll distribute the last time to give us positive 24x squared. Okay, so again, we multiply coefficients just like normal. So like 3 times 2 gives you 6. But with exponents, if we're multiplying them, we just add their exponents. So 2 plus 2 gives you 4. 2 plus 1 gives you 3. And 2, and this could be like x to the 0 if you really wanted to write it that way. That would give us x to the 2. Okay? All right, so then let's also talk about factoring out the greatest common factor. So we can always factor out the greatest common factor for the numbers and also for the variables. So if we look at A, the greatest common factor for the numbers would just be 1. Okay, you could put a 1 in front of the x squared if you'd like. But still, the only thing that can divide 1 and 4 is 1. So our greatest common factor for the numbers would be 1. And then for the variables, it will always be the smallest exponent. So here we have an x. So we'll take out a 1x. Okay, so our greatest common factor is x. 1 times x is x. And then we need to make sure we have whatever's left. Okay, and to do that, we just divide both sides, or we divide it by x. So we end up getting x minus 4. Okay. Maybe I should say that a little better. So when you factor out an x, we also need to divide everything by x. Otherwise, the equation won't, or the expression won't be balanced. Okay, you can't just magically multiply everything by an x. So if we keep it balanced like that, then yes, we end up getting x times x minus 4. You could always check and make sure you got it by distributing it back, and that would give you x squared minus 4x, which is what we started with. Okay. I didn't go over all of these in class, but I will just in case you want extra examples. So greatest common factor for the numbers, well, we have 3, 2, and 4. Okay, in class we had the example if we wanted to, we could do like factor pairs. So 3 could do 1 and 3, and that's it. With 2, you could do 1 and 2, and that's it. And with 4, we would have 1 and 4, and 2 and 2. Okay, so and then we'd want to find ones that are in common. So 1 is always a common factor, but then 3 doesn't go into 2 or 4, so 1 would be our greatest common factor. And then we'd look at the variables. Which is the smallest variable, smallest exponent? Here would be b. So we'll take out a b, but then we also need to divide everything by b. So we'll end up having b times 3, and again, when we're dividing like bases, we subtract. So b to the 3 minus 1 would give us b squared, plus 2b to the 1, or just b. Okay, so 2 minus 1 is 1. And then b over b, that leaves us, they cancel out. Okay, so you need to make sure you do it to all 3 terms. Okay, so I'd like you to try and do a couple of these. So pause and do whatever you feel like you need to. Here we'd look at this and say, well, we have a leading negative, so we'll take out a negative. We have 6, 2, and 10. So the only things that multiplied to give us 2 is 1 and 2. So can 2 go into 6 and 10? Yes, so our greatest common factor for the numbers would be 2. And then we'd want to find the smallest exponent, which would be x to the third. We need to divide everything by negative 2x to the third as well. So we'll get negative 2x to the third times negative 4, or 6 divided by negative 2 gives us a positive 3. 5 minus 3 gives you 2, so x to the 2. Here we've got 2 divided by a negative 2 gives you a negative 1. And then 4 minus 3 gives you 1, so we'll just get x to the 1. And then we have negative 10 divided by negative 2 gives you a positive 5. And then x to the 3 over x to the 3, those cancel. Okay? And let's try this one. Greatest common factor for the numbers would be 1. Okay? Because this would be like a 1, this would be a 1. And then for the variables, this would be the smallest. So that would be y. We'll just divide everything by y, and we get y times 5y to the 5. So 6 minus 1 is 5, plus y to the 3 minus 1 gives you 2, minus, and then we have y over y. Y over y, those cancel, so we just get 1. Okay? Here we have 1. Let's see what's the greatest common factor. Well, the coefficient for x to the 5th is just 1, so the greatest common factor for everything would have to be 1. And then for the variables, it would be x squared. So we'll end up getting x squared times, and then we'll do 5 minus 2 gives you x to the 3, plus 2 times x to the 2. 4 minus 2 gives you 2. Minus 10x to the 3 minus 2 gives you 1, plus 20 times x squared over x squared, those cancel out. Okay, and then we'll try f. So here we think we got some of both. All right, 4 goes into 1 and 4 and 2 and 2, so we just want to see if 4 can go into all of those numbers. Okay, and it turns out that you can, so we'll just choose 4. And then the highest exponent would be a to the 8. So we'll divide everything by 4a to the 8. 4a to the 8th times, so 4 divided by 4 is 1. And then we'll do 12 minus 8 gives you 4, so a to the 4. Negative 64 gives you 16. So negative 16a to the 11 minus 8 gives you 3. And then 8 divided by 4 is 2. And 9 minus 8 is 1, so x to the 1, or just x. And then negative 48 divided by 4 gives you a negative 20, or sorry, not, or, yes, 22. No, sorry, 12. 12, my bad. 12. And then a to the 8 divided by a to the 8, those cancel out. Okay, so if you have any questions about factoring out the greatest common factor, it's going to be important still on this unit. So you'll still be doing greatest common factors on many of the problems that we'll do. Okay, so describe what the greatest common factor is in your own words. Okay, it could be something like, the greatest common factor is the number that can divide every single term evenly. Okay, and it includes leading negatives, so don't forget leading negatives. I don't think any of these had leading negatives, but okay, consider this problem. Let's get into the stuff that we'll be covering today, new stuff. Okay, so consider this problem. What is the greatest common factor? And you'd look at that and say, well, we could do 4. Does 4 does 1 and 4 and 2 and 2. We could do 20. That does us 1 and 20 and 2 and 10 and 4 and 5. We could do 3, does 1 and 3 and 15. That does us 1 and 15 and 3 and 5. Okay, so we'd look at that and say, well, we have a 1 in all of them. There's not a 2 in all of them. There's not a 4 in all of them. So the greatest common factor is going to be 1. So we can't factor out any numbers. Can we take an x from all of them? Nope, we can't because there's not an x in this term. Can we take out a y? Nope, there's no y's in those two terms. Okay, so in this case, we can't take out the greatest common factor, but that doesn't mean that we can't factor. So it says, could you use the associative property to make smaller groups? So for example, could we look at those two, and could we look at those two, and see if there's a greatest common factor between those individual groups? Okay, and you can. So that's what we're going to be doing today, is called factoring by grouping. If you're given 4 terms, and you're asked to factor, you may want to consider factoring by grouping. And that would be like pretty much all the time. So if you find 4 terms, think grouping. When we factor by grouping, we are going to split the expression into groups. Okay, that's why it's called factoring by grouping. And then we're going to take out the greatest common factor for each group. So I have the steps here. I don't have it in the notes, so if you need to pause and write that down, but we're just going to go over the problem. So if you need to see that, pause. All right. So here, grouping. First thing is we're going to make groups, 2 groups. Basically, we're going to cut it in half. Okay, so cut it in half, and then we're going to take out the greatest common factor for just the left side. So we'll do the same sort of problems. We'll put a parenthesis. We'll write out what the greatest common factor is. So here for 4 and 20 would be 4. And then for the x's, we could take out an x. We'd also need to divide everything by 4x. So that would give us 4x, would be our greatest common factor from here. And then we just simplify, we divide by 4x. So 4 over 4 gives you 1, and 2 minus 1 gives you 1. So we just end up getting an x. Here we get 20 divided by 4 gives you plus 5, and x over x, those cancel out. So we end up getting 4x times x plus 5. And now we're going to do the same thing on the right side. So we'll put it in a parenthesis, and we'd take out the greatest common factor. So the greatest common factor there would be, well, we have a leading negative, and 3 and 15, we can divide both of those by 3. We can't take out an x because there's not an x in this term, but we can take out a y from both terms. Okay, so negative 3y, and we'll divide everything by a negative 3y. So we'll have minus 3y times, well, negative 3 divided by negative 3 gives you a positive 1. X is by itself. We can't simplify that at all, but we have y over y, and that cancels out. And on the other side, we'll do 15, other term, negative 15 divided by negative 3. That ends up giving us a positive 5. And the y over y, those cancel out. Okay? So let's see where we're at. So step one was to group the first two terms and the last two terms together. Check. That's where we cut it in half. Step two was to factor out the greatest common factor for each group. Check. And the last step is to factor out the common binomial. So this is a binomial, this is a binomial, and they are the same. When you're doing grouping, what's in those two parentheses would and will and should always be the same. Okay, if by chance you made if they're not, then you made a mistake and you need to go back and see where the mistake was. Like, for example, say a common mistake is not to factor out the leading negative. So say you took out a positive, then this would be a positive and those would be negatives. And would say, well, those aren't the same. This one has x plus 5, this has negative x minus 5. I made a mistake somewhere. Okay, so always check that every time. They need to always be the same. Okay. All right, and then, yeah, the last thing was said to factor out, it says, factor out the common binomial. So to do that, easy way to do that is just to take those both out to the front, factor it out to the front, and then everything else will be in the other parenthesis. Okay? And if you really wanted to check, perhaps you could distribute. You could use a box method to get back to where it started. Okay? So that is how you do factoring by grouping. If you feel like you got that, then you're welcome to just go ahead and work on your homework. I'm going to do a few more examples. Okay? So here again, step one, cut it in half. Greatest common factor for the left side would be 3 for the numbers and x squared for the variables. So we'll end up having, bring that down, we'll have 3x squared times what's left. Well, that gives us, those cancel, and that gives us 3 minus 1, or 2 gives you x. And then negative 6 divided by 3 gives you a negative 2. And then x squared over x squared, those cancel. Okay? And then we'll do the same on the other side. So we'll have the greatest common factor should be 15. Can't take out an x because there's not an x in this term. Okay, so we'll have plus 15. And then we also need to divide everything by 15. So that gives us x minus 2. And if you see, these are the same, what's in the parentheses, so we'll factor those out. We'll do x minus 2 times 3x squared plus 15. So again, everything that's not in those parentheses go in the second parenthesis. And that would be our answer. Okay, but wait, are we done? Let's check. Can we factor anything else out? So the first term, we have x and we have minus 2. We can't factor out anything else there, but we can factor out the right side. So here we can factor out a 3. We'll divide it by 3. So we'll end up getting 3 times x minus 2 times x squared plus 5. So make sure you fully factor things out, and you'll be great. If you have any questions about factoring using the box method, please just come talk to me. I feel like most of the students prefer this, and I feel like it's easier. Okay? Thanks.